Hi, so I'm really excited. This is the last question on balancing equations and is looking quite complex. It's probably the most difficult question, and we kept it for question number 50. So I would not think it would be a good idea to start guessing, placing a 2 here, a 3 here, and all that. At the end of the day, yes, you're going to have about 188 moles of H2O there at that end. So I don't think we'll be guessing here. So you might want to do the algebraic method. It will be long, but at least you get to do it once. So A, B, C, D, E, F, G, H, I. Are you ready? So let's compare the potassium. We have 4A, because that's K4, right? So 4A and plus B equals D. And let's compare iron. Would have A equals E. Right, let's compare C. Carbon would have 6A equals, where else can I see carbon? Here, H. 6A equals H there. Okay, that's all. Let's compare nitrogen. We have 6A. Where else can we see nitrogen? Look closely. Where else can we see nitrogen? Here, G. Then let's compare what else? Mn, manganese. So we have 6. So we have B rather, and we have equals F. And let's compare oxygen. So we have 4B plus 4C equals 4D plus oxygen is 4 times 3, 12E plus 4F plus 3G plus 2H plus I. Okay, that was long. And then we'll compare the next thing, which is, okay, after oxygen, hydrogen. Hydrogen is 2C equals D. Where else can I see hydrogen? Plus G plus 2I. And then after hydrogen, we have sulfur, S. Sulfur is C. Where else can I see sulfur equals D? And then I have 3 times. So this is basically 3E. And I have F. Okay, that's it. Is sulfur the last one? Yes. So we have about 1, 2, 3, 4, 5, 6, 7, 8 equations, and we have how many unknowns? 9 unknowns. So it's not too bad. Not too bad. We'll just assume here that A is equal to 1. So we'll start our assumption. A is equal to 1. If A is equal to 1, that's good, because it would mean that E, based on this, E is also equal to 1. If A is equal to 1, based on that, H would be equal to 6 times 1, which would be 6. So H is also equal to 6. If A is equal to 1, that would mean that based on that, G will be equal to 6 times A, right? So 6 times 1, which is 6. So G is also 6. Okay, so 4 down, 5 to go. What else can we do? A here is 1. So basically we can say that, let me just write that on another page. 4a plus b is equal to d. If a is equal to 1, then we can say that this holds. Therefore, this holds. D should be b plus 4. B is equal to f. Okay, good to know that. So now let's do. I want to put everything in terms of f. I think that could help me if I have everything in terms of f. So I'm going to start from this. C is d plus 3e plus f. Okay. So let me substitute this into here. So that would mean that 2c would be 2 into c, which is d plus 3e plus f. D plus 3e plus f. So that's 2c. It should be equal to d plus g plus 2i. D plus g plus 2i. Now, I'm trying to make everything in terms of f, but let me see what I can find here. So 2 into d, ordinary d should be b plus 4, and we know that b is equal to f. So, and d is b plus 4, but b is equal to f. So it means that d is equal to f plus 4, right? Because b is f. So we have d, which is f plus 4 plus 3e. I think e is 1. Yeah, e is 1. Plus f again will be equal to d, which is f plus 4 plus g, which is 6, right? Plus 2i. I don't even know what I is for now, so I'll just like leave it there hanging. So we basically have 2 into, this is f plus another f, that's 2f. This is 4 plus 3, that's 7, is equal to f plus 4 plus 6 plus 2i. I mean 4 plus 6 is 10, right? So f plus 10, and then 2 times 2 is 4, f. 2 times 7 is 14, should be f plus 10 plus 2i. Now if you send this f back to here, you're going to have 3f on this side. Then if you bring this 10 back, you have 14 minus 10, which is 4. So this should equal 2i. So this is probably another relationship between f and I. So we'll leave that hanging there. So we subbed in this into here, and we've basically used this two right now. So it just remains this last equation that I have not used. I've also utilized this. It's just that last one that I have not used. So let me use that. I'll just write that here. 4b plus 4c equals 4d plus 12e plus 4f plus 3g plus 2h plus I. Okay, interesting. Now let's see if we can work everything in terms of f. By the way, this is what I is. I should be 3 over 2f plus 4 over 2, which is 2. This is what I should be in terms of f. Just playing with that, just in case I would need to substitute that in here for I, since I really want everything to be in terms of f. So 4b plus 4c, let's see what we can do with that. B is actually f. Yeah, B is f, so that's good. So we have 4F plus 4C. Okay, so I'm having a 4C there. That's 4C that I'm seeing right there. Do I like it? C is actually all this. This is all that I have for C. So maybe I should replace it. I should use it again, maybe. Or I should just even leave it there. Who knows? So 4C, let me just leave it first. Then this 4D. 4D. Well, D is supposed to be F plus 4. So 4D should be equal to 4F plus 4. So that's what I'll do. 4F plus 4 plus 12E. E is already 1. Plus 4F, then plus 3G. G is already 6 from here. Plus 2H. What's H? H is 6 as well. Plus I, which I can also express in terms of F. Now, let's just try to simplify this first. So I have 4F plus 4C is equal to, this is 4F plus 16 plus 12 plus another 4F plus 18 plus 12 plus I. So this 4F can take away that 4F happily. So that means that 4C should be, we have 16 plus 12 plus 18. 16 plus 12 plus 18 plus 12. That's 58. And then we have another 4F. And then we have I. So we know that I is this. That's what I is, 3 over 2F plus 2. Maybe we'll bring that in there, 3 over 2F plus 2. So that's 3 over 2F plus 2 plus 4F plus 58 is equal to 4C. So 4C should be 60 plus, now what is 4F plus 3 over 2F? You see that 4F is the same thing as 8F over 2. Okay, so this is the same thing as 8F over 2. And here is 3F over 2. These other two here, I've merged it with 58 already. So now I have 4C is equal to 60 plus, now 8 plus 3 is 11, so 11F over 2. So that's what 4C is. Now let's come back to this place, because this is what ordinary C is. All these. Is there a way I can express all these in terms of only F? Because C, each C that you have there is, by the way, I've used this one. So each C that I have there is D plus 3E plus F. So let's see if we can use that. Hopefully we don't just work in circles, because that's the only thing I wouldn't like. Alright, so we said C is D plus E, D plus 3E plus F. C is D plus 3E plus F. Okay, and it means that 4C would be 4D plus 4 times 3, 12E plus 4F. So 4C is actually 4D. Now what's the relationship between that D and F? D is supposed to be F plus 4. F plus 4. plus 12e. What's 12e? 12e is going to be just 12. I feel like I'm working in circles already. So 4c is actually 4f plus 16 plus 12 plus another 4f. So 4c is actually 8f plus what's 16 plus 12? 28. So that's what 4c is. It's 8f plus 28. So we'll put that here. We'll put that there. So it means that for that left hand side, we're having 8f plus 28, which is supposed to be 4c. 8f plus 28 equals 60 plus 11f over 2. Equals 60 plus 11f over 2. So now let's send this over here. So 8f minus 11f over 2 would equal 60 minus 28. Now this 8 you're seeing here is the same thing as 16f over 2, because that was 8f, right? Minus 11f over 2. And then the 60 minus 28. Okay, I don't feel like we're working in circles anymore. I feel we're actually heading to a particular point. So 16 minus 11 is what? 5. So 5f over 2 is equal to 32. And that means that f is equal to 64 divided by 5. And I guess that's what it will be. 64 divided by 5. 12.8. But let's just leave it as 64 over 5. That is f. So I'm going to just say f is 64 over 5. I'll just put a box around it. We've gotten our f. Now we can get I. I is 3 over 2 times the f, which is supposed to be 12.8 or 64 over 5 plus 2. Okay, so that's 64 over 5 now, or the 12.8. Once you times it by 3 divided by 2, you get 19.2. And when you add that 19.2 to 2, you get 21.2. So 21.2 is the same thing as 106 over 5. 106 over 5. Okay, so I guess we'll just hold that one. That's our I. That's what it's looking like. Then what else? We've gotten I there. We've gotten f here. We've gotten I here. Let's start from the top. A. What's A? So what's B? B is f. And we've gotten f. So it means that B is equal to, what's f is equal to? 64 over 5. 64 over 5. So A, B, what's C? C is supposed to be D plus, okay. C is supposed to be D plus 3E plus F. So let's work it out. Or you can use this one here. So it means that C is equal to 8 over 4F plus 28 over 4. So we'll use that. 8 over 4 is 2. So 2F. What did we say F was? That. So 2F plus 28 over 4. So that gives us 163 over 5 is equal to C. So that's our C there. 163 divided by 5. So now what's our D? D is supposed to be equal to D is F plus 4. Okay, so F, which is 64 over 5 plus 4, that's 84 over 5. So we can say this is 84 over 5. So A, B is missing, C is found there, D is here, E is here, F is here, G is here, H is here, I. So it's B and I that's remaining. Oh, by the way, B is actually equal to F. So B is here. Okay, so A, B, C. Where's the C? Okay, that's C. D, which is right here. E, which is here. F, which is over there. G, which is here. H, which is here. And I, which is over here. Good. So now everything has been found. It's time to now place everything together and see what we can get. So we'll start from the top. A is 1. B is 64 over 5. I shouldn't be even using, let me use black. A is 1, B is 64 over 5, right? 64 over 5. C is 163 over 5. Remember, if I had made an error in any of these calculations at any point, the whole thing is invalidated. E is 1. F is 64 over 5. G is 6. H is 6. I is 106 over 5. Okay, so these are our numbers. Now I guess it's good to multiply through by 5 because that will probably help us. When we multiply through by 5, we'll then check if we've done the right thing. So this will give us 5. This will give us 64. Okay, this will give us 163. This will give us 84. When we multiply by 5, this will give us 5. This will give us 64. This will give us 6 times 5, so that's 30, 30. 30, 30, and that's 106. So now hopefully this thing is balanced. Hopefully, we're not so sure yet because even what I have on my notes is quite different from what I'm getting here right now. So somebody's wrong. Somebody is wrong. Somebody is wrong. 188. I was thinking that coefficient of for the H2O was going to be 188. Alright, but then this is our answer. Now the only reason why this here may not be correct, as if it's not correct at some point, would be what we've gotten from here. So let me just ensure that everything is looking nice. So yep. Oxygen and hydrogen. 2C equals D and G and 2I. Okay, that's good. Right, so now it's time to check. Are you ready to check? Let's start from our potassium. Potassium on the left is 5 times 4, which is 20, plus 64. That gives us 84. And on the right hand side is also 84. Clap now. It's also 84. So that's good. So the K is good. 84 on both sides. Oh, okay. Okay. 20. 122. We're going to eventually check out everything. But right now, our K is the same. Alright, let's go to the next one, Fe. For the Fe, we're having 5 on that side. And on the other side, we're also having 5. That's good, that's good, that's good, that's good. Fe is fine. For the carbon, it's 5 times 6, 30. So we're having 30 here for carbon. What else? On this other side, our carbon is 30. Wonderful, wonderful. Carbon is all good, and all fine. Next is our nitrogen. Nitrogen is 5 times 6. 5 times 6, which is 30 on this side. There's no other nitrogen here aside right here, which is also 30. Yes, so the nitrogen is fine. Next is, okay, we already checked potassium. Potassium was 5 times 4, which is 20, right? Plus 64, that's 84, and we also had 84, good. So we've checked potassium. Manganese, Mn, is 64 here, and then on the other side is 64. Wow, that's also awesome. That's also good. Next is oxygen. Oxygen on the left hand side is 64 times 4. Let's do that. 64 times 4, that's 256. 256, and then we have an extra 163 multiplied by 4. So if you add everything, you're going to have about 908. That's the amount of oxygen you have. 908. Now let's figure out what we have on the right hand side. There we would have first 84 times 4 plus we will also have 5 times 3 times 4. 3 times 4 is 12 already, right? 12 times 5, 16. Plus, we have 64 times 4. We have 30 times 3, which is 90. We have 30 times 2, which is 60. We have 106 times 1, which is 106. And if we do that, we're going to have 908 in total, meaning that our oxygen is also balanced. So we just checked out the oxygen. Now it's time to check out the hydrogen, and then so forth. So hydrogen time, so we have 163 times 2, which is going to be 326. That's how many atoms of hydrogen we have on the left. Now on the right, I'll just write this one down so I remember. On the right, we have 84 first. That's 84 hydrogen. Then we also have an extra 30. Is that all? 30. Okay, so there's something here, 106 times 2. We also have that. Do everything, you have exactly 326. Yes, so our hydrogen is also balanced. That's correct. What else? Sulfur. We have 163 lots of sulfur from here, so that's 163. And there for the D we have 84 plus, yes, so we have 5 times 3, that's 15. That's 15. Any other sulfur? Yes, there's a 64. There's a 64 there. So that's also 100. Oh wow, everything is exactly on point. Sulfur is fine, and I believe that should be the last thing, because sulfur should round that up for us. So that means that this whole thing is balanced and is actually this way: 5k4 64 163 84 5 and 64 and 30 and 30 and 106. So these are the actual numbers that would make that stuff valid. Alright, so with this we have come to the whole thing is balanced, and that means that this question is, these are the answers, so these are the necessary coefficients to make it balanced. With this we've come to the end of the session, this tutorial, this crash course on balancing chemical equations. And I'm sure that with this, most of the equations you come across in your lifetime of studying chemistry, you'll be able to balance them. Okay, because aside the very easy ones that we started with from question 1 down to question 25, and then 40 to 50 where we're finding some tough ones, and then right here this 50, which is just very tasking, you notice that you've basically covered all the kinds of chemical equations that you may come across as you're studying chemistry, at least from when you start studying chemistry ever to the university college levels. You should be able to answer any question based on balancing equations using the algebraic method or using your inspection. Yes, as a matter of fact, as you advance in chemistry, you would meet questions that have to do with biological reactions, and those ones are even quite easy, or organic reactions basically, because most times it's just a one-to-one, a big molecule or an enzyme and a substrate, just one-to-one or maybe 1-2. It's not usually even so complex like that. Yes, but we've played with the complex things, we've played with the easy things, and I'm sure that you are able to go on with your life in chemistry and do great and mighty things. So once again, my name is IK. It has been fun solving these questions with you, and I guess I'll see you on the next course basically. So yeah, I think the next one would probably be something on gas laws, because I know that a lot of people struggle with gas laws, all these Boyle's law, Charles law, Avogadro, Geluza, pressure law, this, that. Yeah, I'm sure some people are not even aware that the pressure law is actually also called, is it the Gay-Lussac law now, that's related to the pressure law, and then it's different from Dalton's law of partial pressure. Yeah, anyway, we're going to talk about those sort of things. It will probably be another stretch of solving questions and then teaching you in between as we go on. And of course, every time that you see me up here, just know that you can reach me easily, or any other chemistry tutor in our with copy chemistry basically, because our goal is to help you understand chemistry better and also to provide support to people that need extra help. This is question 50. I actually recorded up to 49, and then I stopped because I had like a private class I needed to take, and then I continued with recording 50. It's actually fun, right? It's actually fun. So if you need private tutoring, you can also reach out. Our DMs are open. You know the website by now, copychemistry.com. You can book a lesson there. Super fast, super easy. I think we have one of the most responsive customer service anywhere. Most responsive. Yeah, so you can't say, oh, they didn't reply to you. No, they will reply to you. So that's it pretty much. I shall see you on the next one. If you're watching this on YouTube, subscribe so that when we roll out the next set of videos, you will get them. Okay, it's always very entertaining and educative as well. And I'll see you on the next one. Bye. I don't feel like leaving, but I have to leave. I have to leave. I'll see you guys. Bye.